choices in my life. I can see clearly the night has gone. I feel rejuvenated and reborn. Seems impossible until it's done. Let's not stop now, for we have just begun. I see the light. I see my purpose right before me. You're calling out to me as I focus on the path. I see the light. I see the light. I know the skill that lies within me and a will that's formidably breaking out into the night. I see the light. I see my vision. I feel the passion. I feel the pain and the glory. I see my purpose. I seize my moment as I'm rewriting history. I see the light. I'm on my very own journey. I'm on my way. No comparisons, no matter what they say. I have a lifetime of learning ahead of me. Yes, I learn to be the best version of me. I see the vision. I feel the passion. I feel the pain and the glory. I see my purpose. I seize my moment as I'm rewriting history. Oh yeah, I see the light.
Good evening, everyone. Thank you so much for joining the session. Today is day 2. I welcome you for this 30-day masterclass on CORTEX info. Firstly, I would like to welcome Naveen Kumar, welcome, Girish, welcome, Vignesh, welcome. Yes, I'll summarize. Adarsh, welcome, Sultan, welcome, Saurav, welcome, and Janani Shri, welcome, and Janvi, welcome, Nandakumar, welcome, Anuja, welcome, Irlappan, welcome, Sivadarshini, welcome, Shivam, Vignesh, welcome, Rajendra, welcome, Pratik, welcome, Abhishek, welcome, and Pavan Kumar, welcome. Good evening, Ruchita, welcome. Okay, Ahmad, welcome. Gopi Reddy, welcome, and Prasad, welcome. Prasad Suraj, welcome. Yashwant, welcome. Sanu, welcome. Ramesh, welcome, and so thank you so much. If I'm audible, just say loud and clear on the chat box. I'm audible. You can call me by name, G or MK. Okay, please don't call me as sir. I'm comfortable with my name. I'm okay if you call me by name. Okay, call me as Jiva or MK, whatever which is comfortable for you. I once again thank you for joining the sessions. Let's go for the session today. I'll share the screen. Just give me one moment. Okay. So I'll recap like what we have caught up yesterday. So yesterday's session we have caught up what is embedded system design. The definition of embedded system design we covered up. Like it's a combination of hardware and software with some mechanical parts to perform a specific task. We covered up a few more examples for embedded system design. Okay, and we have caught up classification. Okay, classification of embedded system design. Like what is hard real-time, what is soft real-time systems, and we have caught up what is network embedded systems, what is mobile embedded systems. Okay, and different types of processors. What are the processors and controllers available in the market? We have caught up like microprocessors, microcontrollers, DSPs, okay, CPLDs and FPGAs, system on chip, TPUs, tensor processing units, and we have caught up the difference between what is the difference between a microprocessor and what is the difference between a microcontroller, and one example for microprocessor and one example for microcontrollers, and we have caught up the basic features of digital signal processing, and what is the difference between a DSP processor and a general purpose processor and a microcontroller. We have caught up. What is von Neumann architecture and what is Howard architecture, and why do you need DSP processor, and what is CPLD and what is FPGA? What is the difference between a CPLD and a microcontroller? What is the difference between the FPGA and microcontroller? And when to use DSP and FPGA? We have caught up when to use DSP and FPGA, and how you can reduce the number of chips when you go for an FPGA. Okay, we have gone through this example. I have already shared this PDF to your WhatsApp. Okay, and configurable system on chip. We have caught up multi-core processor like what is symmetric multi-core processor, what is asymmetric multiprocessor, we have caught up. And one example, like what is TI warm-up series, and how FPGA is different from ASIC, we have caught up. And comparisons, okay, comparisons, and how to select packages, and what tools you have to use when you choose a specific package, we have caught up. And how to convert an idea to a prototype, okay. So these are the things which you have caught up yesterday. So today's session is all about the ARM architecture, okay. If you're ready to learn, just type RTL in the chat box. Once again, thank you so much for your time, for being here. I really thank you for your time and patience. If you just type RTL, if you're ready to learn, just type RTL in the chat box. Let's go for the session. So today we'll be covering up the ARM Cortex M4 architecture, okay? ARM Cortex M4 architecture. And is there anyone who is attending for the first time? Anyone who is attending for the first time, you didn't attend the session yesterday, and this is the first session for you, I would like to personally welcome you. Just type first time on the chat box, okay? If you're attending for the first time. Manoj, thank you. Kishore, thank you. Ruchita, thank you. Rahul, thank you. Rahul, Subhash, thank you. Srilata, thank you. Janani Shri, thank you. Okay, Janani Shri is first time. Okay, welcome. Okay, Harpreet, please do stay till the end. I'll share you both the PPTs through Google Drive during the session itself. Okay. Shreya, first time, welcome. Anuja, first time, welcome. And Magna, first time. Prem Kumar, welcome. Mahalakshmi, welcome. Okay. Omkar, welcome. Bhaskar Rao, welcome. Venkat Ravi, welcome. Amir, welcome. Okay. Mustafa, welcome. Arun, welcome. Parthi, welcome. And Vinayak, welcome. Swastik Kumar, welcome. Kishore, welcome. Sanu, welcome. And Monica, welcome. Okay. Thank you so much. You can call me Venkat Ravi, like you can call me as MK or Jiva. Okay. Don't call me as sir. I'm comfortable with my name. Please call me by name. Okay. Thank you so much. Okay. Sultan, first time. Okay. Sultan, first time. Welcome. Charita, first time. Saurabh, welcome. Sumita, welcome. Welcome. Okay. Let's go. So I'll introduce myself. My name is Jeevarajan. Okay. You can call me as like my full name is MK Jeevarajan. Like the international students, they call me as MK. You can call me by name. So I have 20 plus years of experience on designing this embedded system design. I don't have any experience on any companies. I straightly came from college and I started this company called Pantech Solutions. So far, like I have generated 70 plus crores for revenue for my own company. The best product, I have designed more than 300 plus products for my own company along with my team. Okay, based on microcontrollers, DSP process, FPGA. We also we are also into software products. Like we have a product called growthflow.ai, which helps business automation for MSME business, like doing marketing automation as well as sales automation. And the best product I designed so far is BrainSense. Okay, which is EEG device, which is selected as the top 5 innovation products in India the year 2015 by NASCOM. Okay, I have sold more than 6,000 units on that BrainSense alone. Okay, if you want to connect with me, there's a LinkedIn link on the chat on the presentation. Like you can search for MK Jeevarajan on LinkedIn. Send me a connection request. I'm happy to connect and happy to help. Okay, so that's all about me. Let's go for the session today. So let's start with ARM. Okay, so ARM, like advanced RISC machines. So initially the name was Akan Computers. They started this company in the year 1994. Okay, this ARM company, they do not manufacture any microcontrollers, okay, or any DSP processor. They just design only the core architecture. Okay, core processor, core. It means they have the core, they have the intellectual IP core. They call it as an IP core. IP stands for intellectual property, where they license the core for the manufacturers. Okay. So the manufacturers like Texas Instruments, Microchip, Analog Devices, there are more than 100 plus manufacturers, microcontroller manufacturers and DSP manufacturers. They purchase this license from the ARM company and they manufacture their own microcontrollers and DSP processors. Okay. So ARM specifically, the embedded revolution starts only with the ARM processor. So before that, before ARM, it's only Intel architecture. Okay. Intel 8085 architecture, 8086 architecture. You have 8051 architecture. They are from Intel. Okay, so ARM, they are based on the RISC architecture. Okay, in computer architecture, basically there are 2 types. One is the reduced instruction set computers. The other is the complex instruction set computers. So the Intel architecture was based on the complex instruction set computers, whereas the ARM they designed their core based on the RISC architecture to perform the instructions, to execute the instructions. Okay. Specifically, they targeted their architecture only for the embedded devices, only for the microcontrollers. Okay, only for microcontrollers. They want to dominate the market. So the mobile revolution, the embedded revolution starts only after the ARM architectures. So they have the RISC architecture, and ARM they have high code density. What does that means? It means you can store more programs in a lesser memory, and it also has power efficiency. It means it can operate on the low power voltage. It can operate on 3.3 volts, 1.8 volt. Okay, so that the microcontrollers can be battery operated. Okay, most of the embedded devices they should be battery operated because they want to stand on battery power. So ARM they come up with the RISC, high code density and power efficiency. So they started designing this core architecture based on this three philosophy. Okay, do we need to have a license if you're using ARM devices? No. See, the license is only for the manufacturers, not for you. If you are purchasing a microcontroller, no need to purchase the ARM license. But if you want to manufacture a microcontroller, then you have to purchase a license from the ARM company. Okay, only when you want to manufacture a microcontroller, not the board. Okay, the board is different. The embedded board is different. So if you want to manufacture a microcontroller, you have to purchase a license from ARM company. Okay, so basically, you have the processor as well as architecture. So every processor has its architecture. Okay, I'll give you an example. Like if you go for the processor, like the product family starts like this: ARM1. They started with ARM1, ARM2, ARM2AS, ARM6, ARM7. ARM7 was widely used. Like I think you might have studied like LPC 214, right, on your curriculum. Okay, ARM7. It's based on the ARM-v3 architectures. Okay, so every processor has an architecture inside. So for us, we are going to deal with CORTEX architecture for this 30-day program. So if you check out the CORTEX series, okay, like a CORTEX M series, so it's CORTEX M4. We are going to use CORTEX M4. So the architecture is based on ARMv7E-M. Okay, so what does it mean? You need to download 2 datasheets from the ARM company itself. So if you want the details about the instruction set, if you want the details about the programmer's model, about the registers, details about the registers, and details about the exception model, interrupts, and memory map, you have to download from the architecture reference manual. Okay, because every processor is based on the ARM architecture. Okay, if you want to know the details about the ARM processes, like timing informations, then you have to refer the technical reference manual, ARM processor technical reference manual. Both this architecture manual and the processor manual has to be downloaded from the ARM website. Okay, you know this point. So if you're using a microcontroller, like STM microcontroller, like STM32, the controller what we are going to use on this series is STM32F411. Okay, it's microcontroller. If you want much more details about the peripherals, like UART peripherals, if you want the register details about the UARTs, serial peripheral interface, I2C interface, or watchdog timer, or those things, you need to get the information from the ST Microelectronics website, not from the ARM website. Okay, so Texas Instruments. So those details, the peripheral details and the registers the manual has to be referred from the Texas Instruments website. If it is a TA based microcontroller, microchip has to be verified on the microchip website. So okay, so the peripherals. If you want the details about the ARM architecture and the processor, then you have to refer the ARM architecture reference manual and processor technical reference manual. Okay, so totally you need 3 data sheets. Okay, apart from this, we have the product data sheets, like the microcontroller data sheets, and the user manual, like for writing the program. Because this program, all the next 28 days, we are going to refer only the data sheets. Okay, and we are going to write the program. We are going to write the program from scratch. So you need to know like what architecture it is, what processor it is, and like what is the manufacturer. Okay, if this is clear for you, just clear on the chat box. Is that clear? Okay, so like I would like to confirm, like is video is visible and my voice is clear? Like you just type visible loud and clear on the chat box, because there are a lot of people who are complaining like the video is not visible. Okay, video is not playing. Like Gudu Kumar Singh is like, yeah, you'll get the PDF. I'll share you the PDF at the end of the session. Please do wait till the end of the session. I'll share you the PDF. Okay. Is that visible? Okay. Karthik, thank you so much. Karthik, thank you. Vignesh, thank you. Okay. Purnima, thank you. Okay, let's go for. Okay, so the next comes the processor families. So when you check out, if you check out this list of ARM processor, okay, I'll show you the list of ARM processor. So you have Cortex M series. See, you have, it starts from ARM1, okay, ARM1, ARM2, ARM6, ARM7, ARM70, 70, ARM7E, ARM8, ARM90. These are different types, okay. Secure core series, Cortex M series, you have Cortex M series. After Cortex M, Cortex R series you have, and Cortex A series you have, okay. These are different series of microcontrollers from the ARM, like you have Neoverse, okay. Okay, so these are the different types of architecture, okay. Now let's, so in Cortex family, you have different types, Cortex A series. So the A stands for application. So what does it mean? If your application needs an operating system, like if you want to port an Android OS to the microcontroller, say for example, you want to implement a smart TV, okay, or a smart books or a digital smartphones. If you want to design a smartphones, then you have to choose this Cortex A series, which is suitable for implementing applications. Like if you to implement, to download RTOS on the microcontrollers. Okay, if you are dealing with the real times, say for example, if you want to implement airbag, okay, airbag on the car, which is a hard real-time systems. The real-time system means the system has to complete the task within a specific deadline. That is real-time systems. Okay. So if you want to design a hard real-time systems or any real-time systems which is time specific, in that case you can go for Cortex R series. Okay. The next is Cortex M series, which stands for microcontroller. So any generic applications, simple applications, if you want to, it's cost sensitive, it's very low cost. Okay, in that case you can go for Cortex M series for any microcontroller applications you can develop on it. And secure core series, there's one more series called secure core series. If you're going to implement IoT based applications, okay, where you need security, okay, where you want to implement cryptographic, where you need to encrypt the data, in that case you can go for secure core series. Okay, so is that clear? The Cortex A series, Cortex R series, Cortex M series, and secure core series, the application of each one of them. Is that clear? Just clear on the chat box. We'll go for the next one. Okay, if you want me to repeat, I'll just repeat. Okay. Prem Kumar, just check out, like, because like the audio, everyone is telling the audio is clear. Okay. Okay. So I'll just repeat. Cortex A series stands for application. Say if you want to implement an RTOS, like if you want to implement Android OS operating systems on your microcontroller, then you choose Cortex A series microcontroller. Okay, which is suitable for smartphones, digital TVs, and for smart books. If you want implement a real-time systems, like say for example airbag, okay, in that case you go for Cortex R series. Okay, R stands for real-time. And if you want to implement a simple microcontroller application, simple embedded system design, then you go for Cortex M series, which is cost sensitive, like which is very low cost. Okay, and secure core series for especially if you want to interface, if you're going to interface with IoT applications, or if you want to use for IoT, like where you need security. Okay, where you have to implement a cryptographic. In that case, you go for secure core series. Okay. So basically, the ARM architecture comes with extensions. Okay, you have the ARM instructions and you have the thumb and thumb2 instructions. I'll tell you what is the difference between the ARM thumb and thumb2 instructions. Okay, so ARM instructions has higher performance, but the code density will be very less. It means like it occupies more area. Okay, whereas when you go for the thumb instructions, the code density will be higher. You can store more codes on a lesser memory, whereas the performance is low. Okay, whereas when you go for a thumb2 instructions, the code density is higher, the performance is also higher. Okay, so you need to check the data sheet whether your processor supports thumb instructions or thumb2 instructions. So the ARM processor can support both instruction set, ARM instruction as well as thumb instructions. can implement 32-bit both 16 as well as 32-bit instructions. Okay, and it can handle 32-bit operands. Okay, that's the difference. Thumb and thumb 2. So thumb 2 is has higher advantage than thumb instructions. So you need to check whether whether the process supports thumb instructions or thumb 2 instructions. So the ARM7, when you go for ARM7 TDMA, okay, the T stands for thumb instructions. In Cortex M series, by default it is thumb. Okay, by default it also supports thumb 2 instructions. So the T bit is set always. Okay, for the Cortex M series. So these are the architecture extensions. Okay. Now, coming to this bus systems. Okay, AMBA stands for Advanced Microcontroller Bus Architecture. Okay, so how the core is connected, the ARM core is connected to the peripherals. Okay, so the ARM core. So what is it? So what is the content of the core? It has the registers. You have the programmer's model. You have the registers, and like the program counters and link registers and status registers. Everything will be on the ARM core. Apart from this, you also have the controller, like the interrupt controller, wake up controller. Okay, so everything will be on the ARM core. I'll cover up in much more detail what is ARM, what is inside the ARM core in the next slides. Okay, so the ARM core is connected to the AHB bus. AHB stands for Advanced High Performance Bus. Bus is nothing but a series of wires. Okay, you assume that it's a wires inside. If you inside the silicon, okay, inside the microcontroller, you have the ARM core as separate, and you have a bus which is connected to the high speed, high bandwidth memory interface. So all high speed devices can be connected to AHB. Like high speed devices means like the memory device, flash memory, DDR, SDRAM. Okay, so all these memories can be connected to the advanced high performance bus. And this high performance bus is connected to APP bridge, advanced peripheral bus. Okay, which is connected to APP bus, advanced peripheral bus, where all the peripherals are connected, like keypad, UART, timers, display, RTC, IO. Okay, so the DMA is connected to advanced high performance bus. You need to understand this bus system because you need to if you want to blink an LED or interface a switch, you have to trigger the clock for the bus. So you should know. So the peripheral, say for example, if you want to blink an LED, so this GPIO, the LEDs, you have to know which GPIO has been connected, and the GPIO is connected to which bus. Okay, so that you have to enable the clock access for the bus. Okay, only then you can write the code. So you need to understand this bus architecture. I'll explain you in detail about the functional block diagram later. Okay, so just I want to ensure that, are you clear with this AMBA system? It's a architecture. It's a bus architecture. How it is connected to the peripherals and other high-speed devices. This block diagram explains how the ARM core is connected to the other high-speed devices through the bus. Okay, bus is nothing but a series of wires. So two buses there. One is advanced high-performance bus, where all the high-speed devices you can connect it to the advanced high-performance bus, where it can be high-speed and it can be low-speed, where all the peripherals has been connected to this APP bus. So the APP bus and AHB bus is not directly connected. It is connected via a bridge, APP bridge. So when I say bridge, you can have one APP bus or two APP bus. Okay, so in our microcontroller STM32F1, we have two APP bus, APP1 and APP2. Okay, is that clear? If it is clear, just say clear on the chat box. If you want me to repeat, just repeat on the chat box. I'll go through a chat. I'll go with the majority. Okay. So, yeah, RTC stands for real-time clock. Okay. See, UART stands for Universal Asynchronous Receiver Transmitter. Don't worry about these things. We are going to cover up in detail. Okay. What is UART? How it works? What is timer? What is RTC? Everything we are going to cover up in detail. So these are all the peripherals. Okay. Okay, Rishi Khatri, like what is the meaning of ARM core? Please hold. Like I'll give you a clear explanation. Like what is the ARM core, the block diagram, what is inside the ARM, because everyone has this confusion. What is that core? What is that core? They want to know what is that core. Okay, please stay patient. Like I'll cover up in detail the next slides. Okay, this is for Rishi. Yeah. Okay. So thank you. So see, no, see in this block diagram, don't worry about what is UART, what is timer, like what is display, what is RTC. These are all peripherals. These are all peripherals for microcontroller. Like timers are used to generate delays, okay, and to count the external events. So all these are, you need to understand in this block diagram. You need to understand how this peripheral is connected to the ARM core. Okay. So now, as of now, you don't have much knowledge about what is inside the ARM core. Just hold on, I'll explain in the next slide. Okay, in this block diagram, what the key takeaway is, there are two kinds of bus in this architecture. So AMBA is a is an architecture. Okay, advanced microcontroller bus architecture. Okay, AMBA stands for advanced microcontroller bus architecture. So all the high speed devices are connected to AHB bus, advanced high performance bus. Okay, all the high speed and low speed is connected to, all the peripheral are connected to the APP bus, advanced peripheral bus. So the APP bus is connected to AHB via a bridge, okay, APP bridge. And so DMA, even DMA and memory interface and high on-chip RAM, everything is connected to AHB bus. This is what you have to understand. Don't worry about your timer, display, RTC. We'll be covering up in the next slides. Okay, is that clear? Is that clear? Thank you so much. Abdul, please don't call me as sir. I repeat again and again. It's for everyone. Please call me by name. Okay, call me by name. So thank you so much. Okay, Rishi, thank you so much. Okay, you put us a public. Okay, so now let's go for. See, this is a slight detail, much more detail about the architecture here. This is an example. We have the ARM processor. Okay, ARM processor. So the ARM processor core is connected to an interrupt controller. See, all this yellow are controllers. Okay, have memory controller because you have different types of memory. You have flash memory, you have SRAMs, SDRAMs. So it needs a controller for it. So all these memories are connected to AHP, Advanced High Performance Bus. Okay, you need to understand this. See, AHP arbiter means it's a controller which manages the bus. Okay, when multiple devices request for an access, so the arbiter will will provide you which device to get access to the bus. Okay, and you have a AHP and APP bridge. So all the peripherals, the green color are all the peripherals. The RTC, Ethernet, timers, and USART is connected to the APP bus. Okay, so both are same. This one and this one are same, but it gives you overview of the controller part and the peripheral part. Okay, now coming to the memory types. So you can interface different types of memory to the ARM architecture. You have a read-only memory, cannot be programmed, cannot be reprogrammed. It's a one-time programmable. Okay, you have flash RAM. Most of the microcontroller comes with the flash RAM. It means you can write and you can read. Okay, and you have DRAM, dynamic random access memory. Okay, and you have SRAM, static random access memory, which is faster than DRAM, and you have SDRAM, synchronous dynamic random access memory. After SDRAM, you have other memories like DDR SDRAM, DDR2 SDRAM, okay, and mobile DDR. There are a lot of memories after that. Okay, so SRAMs and SDRAMs, DRAMs are all like volatile memory. When you power off, the controller will go off. The flash memory and EEPROM are all non-volatile. It means even when you power off, the program will be there. You need to understand only this. Okay, flash memory, it's non-volatile. So SRAMs and SDRAMs are used for storing data. Okay, say for example, when you have image processing applications, the code will be stored on the flash memory. Okay, but the variable content, the coefficients, everything will be stored on the SDRAM or SRAM. Okay, because the way for flash memory, if you want to store the data, there are certain procedures. You have to erase the previous content and you have to store it. Okay, so whereas when you generate a lot of coefficients on during the runtime of your program, in that case you cannot erase and store. Okay, what they will do is like they will allocate a data memory on this volatile memories like SDRAMs and SRAMs, where you can store the data. Okay, where you can store the data. So this memory type is clear for you. We have two basic types. One is volatile and other is non-volatile. Okay, non-volatile means the program will be there on the memory even when you power off and when you turn on when you after the reset. Okay, even when you power off and when you turn on, like the program will be there. Whereas volatile memory, the program will be erased. The purpose of the volatile memory is to store the data. Okay, the purpose of the program memory, like all the program memories will be non-volatile. It will be stored on the flash memory, on the flash contents. Okay, when you store a program, when you store a C program, the C program will also have the data. Say for example, like you have a global variable called integer a equal to 5. Okay, and that case, initially the program will be stored on the flash memory. Okay, but the startup file will copy the variable from the flash memory and it will be loading that variable on a SDRAM memory or SRAM memory or RAM memory, which is available on your microcontroller, because you will be modifying the variable. Okay, so you cannot modify on the flash content, you can only modify on the RAM content. Okay, because the way you store on the ROM content is different, the flash content is different, the way you store on the RAM content is different. RAM, you can just access the address and you can store the data, you can store it. You can modify the data easily. Okay, but flash, it's not like that. Flash, you have to erase it before you read it, before you write the data onto the flash memory. Is that clear? Okay, is that clear? Just clear on the chat box. Is that clear? So let's go for ARM Cortex M series families. Okay, so ARM Cortex M series, like you have Cortex M0, Cortex M0 plus, M3, M4, M7, M23. These are the architectures. You have ARM v6, ARM v7. So let's focus on Cortex M4. It's ARM v7. The architecture is ARM v7E. Okay, you can see the architecture is Harvard architecture, whereas the Cortex M0 it's von Neumann architecture. Okay, you see the difference. Cortex M0 is von Neumann. Okay, and Cortex M4 is Harvard architecture. It means like the program memory and data memory is kind of a separate bus. Okay, so that you can simultaneously fetch program and data. So efficient way of calculations, mathematical model can be done on the Harvard architecture. So it supports, on the right hand side, you can see the DSP extensions. Okay, it supports, the Cortex M4 supports DSP extensions, digital signal processing extensions. So it supports both thumb instructions and thumb 2 instructions. Hardware multiply and divide it supports. Okay, and floating point is also optional. It means it supports. If you want, you can use it. Okay, so Cortex M4 it also supports DSP applications. But when you compare this Cortex M4 with the traditional DSP processor, like the TMS C6000 series, they are much. To some extent, you can compete with those processors, DSP processors. But if you want to develop a high-end DSP applications, then you need to use only the DSP processor. Okay, but some extents ARM Cortex M4, the basic DSP application can be done by using the DSP extensions available on the ARM Cortex M4. This is just to compete with the market. Okay, they don't want to lose this market, the DSP market. So they have this DSP extensions so that if you have a simple DSP applications, you can do this simple DSP application on Cortex M4. Okay, is that clear? So is this clear for you, the ARM Cortex M series? So all what you have to know from this presentation is, so this the same thing you can also get from the DigiKey website. So Cortex M4, like you have what architecture is this and what is the core architecture, like whether it is von Neumann or Harvard architecture, whether it supports thumb and thumb 2 instructions, okay, and hardware multiply, hardware divide, saturated math, and DSP extensions, whether it supports DSP extensions, whether it supports floating point. So you'll okay, so ARM Cortex M4 it supports option. Floating point is optional. If you want, you can use it. Else, you can turn it off. Okay, and DSP extension is there. Okay, so coming to the core. Okay, this is the core. Okay, so this is the core. Floating point, it can perform floating. Yes, yeah. Floating point unit means it can perform floating point operations. Okay, so that you can have higher precisions, okay? Especially when you use the image processing or audio processing applications, signal processing applications, where without rounding off, because usually what happens whenever you round off the numbers, there'll be a truncation loss. But when the process supports floating point, like you can do the calculations on the floating point and it also supports the IEEE rounding modes. Okay, I'll cover up much more in detail. So coming to the ARM Cortex M4. So what is inside the core? Okay, so this is the block diagram which is inside the core. You have the nested vector interrupt controller. Okay, so wake up interrupt controller. So if you want much more detail about this block diagram, let me show this on the. This is the overall block diagram. Okay, this is the overall block diagram for STM32F411. Okay, this is the IC which we are going to use. It's from ST Microelectronics. So this is the core. Okay, this part is the core. Like JTAG, you have JTAG, you have memory protection unit. Okay, and you have NVIC, and you have the ARM Cortex M4 100 MHz FPU with a floating point unit, and you have D bus, data bus, instruction bus, and system bus. Okay, extended trace macrocell unit. Okay, ETM unit. So all this is the core. The core is connected to the AHB bus matrix. Okay, this is the bus matrix, and you have direct memory access, DMA2 and DMA1. In AHB, there are two types of AHB bus. One is AHB1 bus, the other is AHB2 bus. Okay, and AHB1 bus, again, it is connected to to the bridge, AHB and APP bridge. This is the AHB and APP bridge. From here, you have two bus, APP2 bus and APP1 bus, advanced peripheral bus. See, all these are peripherals, external IT, interrupt wake up, secure digital I/O input output, timers, pulse width modulation. Okay, all these are timers. USOT, universal synchronous asynchronous receiver transmitter. Okay, it also supports UART and USOT. Okay, USOT means clock, and SPI serial peripheral interface. Okay, and temperature sensors, ADC, and you see like I2C, SM bus. Okay, sorry, timers. Okay, you have timers, real-time clock, automatic wake-up unit, power interface, watchdog timer, clock. This is clock. This is the watchdog timer. Like, okay, and you have power on reset, power down reset, brownout reset, everything. Okay, so this is the block diagram. I'll explain in the detail about this block diagram in the next slides. This is to know like what is the core. A lot of people are asking what is the core, what is the block diagram, what is the block diagram of the core, what is inside the core. Okay, so the core contains of nested vector interrupt controller. So this nested vector interrupt controller is used for managing interrupts. Okay, the term it is called nested. It means you can have interrupt inside an interrupt. If you don't know what is interrupt, like interrupt is used like say for example, if I'm talking to you and suddenly the phone rings up, and if I stop taking class and if I go for attending the call, so that's an interrupt. Okay. Similarly, microcontroller when it is processing some execution, or when it is processing a task, when it gets an interrupt from another task, okay, so it stops the current execution and go for the interrupt service routine, and it handles that. It executes that program. After executing the program, it will return back. Okay, so this is called an interrupt. Okay, so the processor puts the current task on hold and it goes for the interrupt service routine and executes on one more task. I'll give you one example. Okay, say for example the crash prediction. So whenever the car is crashed, it gets the crash prediction sensors. The microcontroller gets the input from the crash sensors, and it has to suspend the current operation and has to open the airbag. Okay, within 20 milliseconds. Okay, the airbag has to be opened within 20 milliseconds. So this crash sensor will be connected to an interrupt, so that whenever an interrupt occurs, so it is considered as a high priority interrupt. So even if a low priority interrupt occurs, it will go for the high priority. So the nested vector interrupt controller, it means you can have nested interrupts. You can have a higher priority. So whenever a process is serving low priority interrupts, and whenever a high priority occurs, it puts the low priority in hold and it goes for the higher priority. And one more interrupt, which is much more higher than this two interrupts, it puts both 1 and 2 interrupts and it goes for the third interrupt, which is a very high priority. So it can have nested vector interrupt controller. Okay, I'll cover up in detail in the next slide. What is nested vector interrupt controller? What is inside that block? I'll cover up in much more detail. So as of now, you just take what is the nested vector interrupt controller, like it's to manage interrupts. Okay, nested interrupts on the Cortex core, on the core. And you have wake up interrupt control interface. So whenever the process is in sleep mode, usually what happens, like for reducing the battery time, the processor will be on sleep mode. So suddenly a button is pressed. In that case, the processor has to wake up from the sleep mode and it has to go for the interrupt service routine. So it also have wake up interrupt controller interface to wake up from sleep, okay? And whenever an interrupt occurs, and it has a FPU unit, floating point unit, and it has a CPU with the DSP extensions, okay, MAC capability, multiply and accommodate in the single instruction cycles. And it has the registers like CPU is nothing but all the registers will be here, okay? R0, R1, R2, R3, R4, R15, like R0 to R15 will be stored on the Cortex M4, okay? And you have, sorry, you have the bus matrix to interface, and you have the memory protection unit, have the SRAM. So the bus matrix is this one, like this is the bus matrix. Okay, this it's connected to the bus matrix here, where it is connected to the other buses. Through the bus matrix only, it will connect with the advanced high performance bus. Okay, and it has data watch points, break points, ITM instrumentation trace macro cell, and ETM trace, serial wire viewer, debug access port. Okay, I'll explain you what is there in the upcoming slides. Is that clear? What is inside the core? Is that clear? The block diagram of the core, is that clear for you? Just clear on the chat box. Anyone who asks for what is core, is that clear for you? Clear on the chat box. If you're not still clear, just type not clear on the chat box and go through your chat and repeat it again. Okay. FPU stands for floating point unit. Vishnu, like FPU stands for floating point unit. Okay. See, what is cores? See, Shanu, like cores are nothing but like having more than 2 core on a same package. Okay, 2 cores on a same package is like yesterday we covered multi-core processor. Okay, here we have only single core, the ARM Cortex M4. If say for example the same core is you have 2 cores on a single IC, then it is cores. Okay, 2 cores like quad cores, 4 core. It means 4 cores on a single package, single IC itself. One example is ESP32. ESP32 has dual core. It has 2 cores. Okay, ESP32. But TI OMAP series has 2 cores. 2 different cores. TI OMAP has 2 different cores. One core is ARM11. The other core is Texas Instrument DSP core. Okay, so it will handle the complex DSP. The TI DSP core will, the C6000 core will handle the complex DSP applications. Okay, whereas ARM will take care of all the like touch panels, displays, and all the embedded applications. Okay. Okay, is that clear? Is that clear? See, Abhishek, CORTEX stands for encoder and decoder. Like usually when you say it's meant for audio codec and video codec, like it's nothing but a ADC and DAC, high speed ADC and high speed DAC. Okay, the codec is nothing but high speed ADC and high speed DAC. It's usually used to interface. If you take audio codec, you have microphones and speakers. Okay, microphone is the input and speaker is the output. So when you give an interface to a DSP processor, it has to like the microphone is an analog signal. Okay, you cannot directly feed an analog signal to a DSP processor. It has to convert to a digital signal first, and then you have to feed it to a DSP processor. The codec plays a role of converting that to a digital signal. Okay, encoding process and decoding process. Okay, and like the output out is speaker. The output is speaker. Okay, it converts the speaker. What is the speaker? Like speaker is again analog. So whatever the digital signals you get from the DSP processor, you have to convert that to an analog, and you have to feed it to a speaker. Okay, so that's audio codec. The video codec, the same is for video codec, video ADC and video DAC. Okay, like high speed ADC, like camera, you have analog camera, but there are nowadays like they have digital cameras directly, like they produce only the digital signals. But usually in the older days they also have the analog cameras and analog TVs, okay, where analog signals. But today, like digital, like you have TFTs, you can directly give a display. TFTs, and all those things are digital devices. Okay, but there are like analog TVs and analog TVs are there. Like in that case, you can use video codec, encoder, and decoder. Is that clear for you, Abhishek? Is that clear for you? Yeah, like Paul, like audio is not clear. Yeah, I'll share the PPT. Okay, I'll share this way. So before I repeat this one. Rishi Khatri is again still he's in confusion. Like Rishi Khatri, the core is like a CPU of a microcontroller. Yes, see, the core contains of like what is inside in the microcontroller. What happens inside the microcontroller is like you have adders, multipliers, shifters, okay, of only ALU unit, and you have registers, you have program counters, you have program counters, link registers, you have program status registers. These are all the core. These are all the core. Okay, these are all the core. Because what happens inside a microcontroller is a mathematical calculations. Okay, you have the logic units, logical shift, additions. Okay, only these things will happen inside the microcontrollers. Okay, DSP processor also the same thing. Is that clear? Rishi, is that clear for you? Abhishek, I'll explain you what is ITM and ETM in the next slides. Okay. See, threads are tasks actually which you execute, which you execute on the core. Okay, so like you can, specifically when you have a real-time operating systems. Okay, you can have multiple threads on a single core processor. You got the point? Like for implementing multiple, if you want to implement a parallel processing, you don't need to have two cores. Okay, if you have a real-time operating systems, you can implement two threads parallelly on one single core by using a real-time operating system. So that is thread. Is that clear for you? Sean, is that clear for you? Okay, is the entire bus control is done by control unit on why AHB is divided into two. Okay, I'll come to your point. Say, Tijo, say why AHB is divided into two. Okay, see here, you notice this point. This answer is for Tijo. Okay, APP1 and APP2. We have two APP, Advanced Peripheral Bus 1 and Advanced Peripheral Bus 2. Okay, the Advanced Peripheral Bus 2 is operating at 100 megahertz. Okay, note this point. Advanced Peripheral Bus 1 is operating at 50 megahertz. Okay, it means low speed. Okay, this is high speed, this is low speed. You see here, like the user 2 can have 50 megahertz. The same user 1 has 100 megahertz. What does it mean? Like you can interface high speed devices only to this APP2. Okay, so if you have a high-speed device, then you cannot interface to APP1. That's the difference. Got the point? Did you got the point? If you got this point, just got it on the chat box. Okay. So see, only when you give input on the chat box, I can know like whether the message is received or not. Okay. I want everyone like if you got this point, you have to type yes or no on the chat box. This answers for Tijo. Okay. Shubham, like I'll repeat. Okay, I'll repeat this one, and I'll also repeat like why the bus is divided into two. Okay, so ARM Cortex M4, it contains of the nested vector interrupt controller, which is managed to handle interrupts. Don't worry, what is inside nested vector interrupt controller? I will take much more detail in the next slide itself. Now, okay, the next upcoming slides, I have much more detail about what is nested vector interrupt controller, what is inside the DSP extensions, what is wake up interrupt controller, what is floating point unit. What is data watch points, what is flash, patch, and breakpoint, everything I'll explain you in detail in the next slides. Okay, as of now, in this block diagram, the core contains of all these things. Nested vector interrupt controllers, CPU, DSP extensions, you have bus matrix, because the core is connected to the other peripherals and other high-speed devices only through the bus matrix. Okay, because the bus matrix is one which is connected to the advanced high-performance bus, where all the high-speed peripherals are connected to the advanced high-performance bus. Okay, the advanced high-performance bus is connected to a bridge, APP bridge, where you have two different kinds of bus, APP1 bus and APP2 bus. Both is operating at a different frequency. One is at 100 megahertz, the other is at 50 megahertz. So 100 megahertz means when you have a high-speed device, you can be interfaced with the 100 megahertz bus. 50 megahertz, it's a low speed. Okay, so SRAM's memory protection unit. So all these are debug unit. Okay, I'll cover up much more detail now. Now let's go for. So this is the detailed block diagram of the core. Okay, so you have the Cortex M core here, Cortex M4 core here. You have the floating point unit, and you have the embedded trace macro cell unit. So okay, this block diagram is external like this. Okay, Cortex M4 processor. See this is inside the Cortex M4 processor. You have nested vector interrupt controller. You have Cortex M4 core floating point unit. You have data watch points. Okay, you have memory protection unit, you have flash patch breakpoint, you have ASP access port, bus matrix, okay, instrumentation trace macro cell, trace port interface unit, data watch points, and backup interrupt controller, and serial vendor. Okay, now let's go for the Cortex. See this symbol, this plus icon. Okay, there's a symbol called plus icon. It means it's an optional. If you want, you can use it. Else, you can turn it off. Floating point unit is optional. Nested vector intercontroller is mandatory. Cortex M4 core is mandatory. Embedded trace macro cell is optional. If you want, you can use it. Data watch point is also optional. Okay, memory protection unit is also optional. Don't worry about this. I'll take next slides. Okay, flash batch breakpoint optional. AHB access port optional. Bus matrix mandatory. Okay, serial wide JTAG optional. Wake up interrupt is also optional. Instrumentation trace macro cell optional. Trace port interface unit is also optional. Mandatory is Cortex M core, nested vector interrupt controller, bus matrix, or the mandatory thing. Okay. Now let's go for what is inside the Cortex M core. Okay. See, this Cortex M4 core is based on the architecture called ARM-B7 architecture. Okay. So what is inside the ARM-B7 architecture? You have the register details. How many register it has? R0 to R16. Okay. And what is low register? What is high register? What is program counter? What is program status register? Everything will be on the ARM-B7M architecture. The core is the Cortex M4 core is based on this architecture. So if you want to know the details about the registers and all those things, you need to refer the data sheet from the ARM-B7M architecture reference manual. Okay. And the core also has a stack pointers, banked stack pointers. Okay. It supports both hardware integer divide instructions, both SDIV and signed division as well as unsigned division. It supports both signed division and unsigned division. It supports two modes, handler mode and thread mode. Okay. So thread mode is the normal mode, the execution mode. The handler mode is whenever an exception occurs or whenever an interrupt occurs, the processor goes for the handler mode. It goes for the interrupt service routing. Okay, so it supports two modes, handler mode and thread mode. It supports thumb and debug states. What does it mean, thumb and debug states? So debug, whenever you want to write a program, whenever you're designing for the very first time, okay, the processor can support this debug states. So what is the purpose of this debug state? You can put breakpoints and you can stop the execution of the program at some certain locations, and you can analyze the variables, what is there. You can analyze the registers and everything. If you want to change the variables, you can change the variables. Okay, that can be done on the debug states. Whereas thumb state is the optimized state. Like once it's ready, when you go for the thumb state, the code size will become lesser. Okay, so usually like you have a debug mode and release mode on the compiler part. When you go for IDE, you can see a debug part and release part. When you choose debug, and check the final executable file, which is going to be downloaded on the microcontroller. The size will be much more bigger when you keep it on a release mode. The reason is it has debug information, it generates debug symbols, which is needed for the for debugging purpose. Okay, whereas for thumb mode, like when you go for release mode, like okay, that's an optimized code, like where it reduces the code density. Okay, that's thumb state. So it supports both thumb and debug states. And it also supports interruptible continuous instructions like for LDM, STM, push and pop, which is for low interrupt latency. What is low interrupt latency? It can service interrupt at higher speed. Okay, by using these instructions like LDM, STM, push and pop. Okay, and one more features is like whenever you have an interrupt, okay, the processor itself will save the current state. Okay, no need to have a separate instructions. The processor automatically saves the current state during the interrupts. Okay, so it has that option, and it supports both big Indian as well as little Indian. The way how you store the bits in memory. Okay, from LSB to MSB, MSB to LSB. It supports both little Indian as well as big Indian. Okay, is that clear? Is this slide is clear for you? Just clear on the chat box. Okay, we have caught up only this Cortex M4 core. The next slide will cover up floating point unit. Okay, is this clear for you? Just clear in the chat box. Say I want you to engage on chat. Only then I can know like whether I can go for the next slide or not. Okay. See how many pins, how many pins are there in ARM Cortex M4? See, I'll tell you what. If you choose, if you go for digikey.com, okay, let me show this for you. Digikey.com. Okay. This is okay. Just go for Digikey. I search for ARM Cortex M4. Okay, ARM Cortex M4. Click. I just choose the microcontrollers. Okay. See, these are all the ARM Cortex M4. Cortex A5, A series for application, M series for M series, okay, microcontroller applications, M series, Cortex M series, Cortex M4 is here. Okay, these are all Cortex A5, Cortex M4. Let's see. See everything. There are you have ST microelectronics. Okay, it's not only ST. You also have microchip. See, you see microchip. The architecture is ARM Cortex M4. Okay, and the spin details will vary from microcontroller to microcontroller. Currently, what we are seeing is the architecture. Okay, the core, the block diagram. The pin details will vary from manufacturer to manufacturer. You need to verify the data sheets. Say for example, we are going to use only STM32F411. Okay, so STM32, we need to check for STM32F411. So if I filter only the ST microelectronics, okay, these are all the different type of manufacturers who is manufacturing the ARM Cortex M4. So I choose only ST microelectronics and give apply all. Okay, and let's see this. So I'll get only the ST microelectronics manufacturers for ST microelectronics. So currently we have only 1303 devices. Okay, even 1303 devices. So I'm just filtering again. I don't want Cortex A series. Okay, I want only Cortex M series. ARM Cortex M4 core processors ARM Cortex M4. Okay, so I click this. See core ARM Cortex M4. Click apply all. So if you check out the results now, okay. So this results will get reduced. Again, see 1253. Again 1253 devices are there. 1253 different types of microcontroller are there in the same ARM Cortex M4. Okay, same ARM Cortex M4 because this is a 48 pin IC. This is a 32 pin IC. Okay, this is a 48 pin LQP package, quad flat package. See, this is a 48 pin. Okay, this is 48 pin. So again, if you want to go much more detail, okay, much more detail, I can choose what are the peripherals, number of IOs. See, number of IOs, number of pins, number of IOs. I can choose. Okay, so let's go for STM32 directly. So what we are going to use is STM32F411. Okay, I search for STM32F411. In STM32F411 itself, we have 28 different types of microcontrollers. Okay, see STM32F411. Okay, the package is different. Quad flat QF1 package. Okay, see QF1 package. This is BGA package. 64 pin. This is 48 pin. So even this, all are ARM Cortex M4. All are same thing only, but it depends. So you have to verify. So currently, as we are going only to the core. Don't get more confused. Okay, just take as it is, and then you explore more. Okay. Yeah, you can use DigiKey or Mouser. Okay. So see, the attendance will be given only at the end. Suraj, please don't spam here for attendance. Okay. This will be given only at the end. If you want only for the attendance, you please join at the end of the session. Just come and sign up for the attendance. Okay. Just focus on the learning now. Okay, so I just repeat. See, this automatic process state saving means, so whenever you have an interrupt, or whenever the processor has an interrupt, the processor automatically save the current states, the current registers. It has to store all the, before going for the interrupt, it has to store it to the stack, and it has to retrieve it back. Okay, so automatically the process states its state is saved, and during the interrupt entry, and during the interrupt exits, it restores the states. Okay, it supports both big Indian as well as little Indian access. Okay, now let's go for the floating point unit. Okay, the floating point unit, see, it supports MAC capability, multiplane accumulate instructions, combined multiplane accumulate instructions. It supports 32-bit instructions for single precision. It supports hardware support for conversion, addition, subtraction, multiplication with the optional accumulate division. It also supports IEEE rounding modes. Okay, so that, see, whenever you round off a number, there is a certain format you have to follow as per the IEEE standards. Okay, it supports the IEEE standards, and 32 dedicated 32-bit single precision registers are there. Okay, this is for floating point unit. Okay, floating point unit, it's an optional. If you want, if you can use it. If you want, if you don't want, you can disable it. Okay, the next is NVIC, nested vector interrupt controller. Low latency interrupt processing. It means interrupts can be serviced at highest speed. Okay, the core processor, the actual core from the ARM company can handle 240 interrupts. But when you go through the data sheet, some processor will have only can handle 84 interrupts. The STM32F411 can handle up to 84 interrupts. 84 extension. But the actual core has the extension up to 240 interrupts. It can have up to 240 interrupts. Okay. It is a manufacturer decision, like which to restrict whether to 84 or 100. Say if you take Texas Instruments, it may be 120 interrupts. If you take ST Microelectronics, it's 84 interrupts for a specific IC. I'm talking about only STM32F411. For some other IC, it may be different. So you need to verify how much interrupt is supporting. But the ARM core can handle up to 240 interrupts. Okay, and you can prioritize these interrupts. Okay, you can prioritize these interrupts, and you can group the priority. Once you prioritize the interrupts, and if you want to change it back during the runtime, that is also possible. So dynamic reprioritization is also possible during the runtime of the program. If you want to change the priority of the interrupts, you can still change the priority. Okay, and you can also group priorities. So by grouping priorities, what happens is you can preempt or non-preempt the interrupt levels. So what is preemption? Preemption means, say for example, you get a high interrupt, high priority. So the process is currently serving a low priority interrupt. It puts the low priority interrupt on hold. It preempts and goes for the high priority interrupt. That's called preemption. Okay. So when you group priority wise, whenever a high priority interrupt occurs, it can put all the low priority on hold and it can go for the high priority task. The process state automatically saved on interrupt entry and restored on interrupt exits with no instruction overhead. Without any additional instructions, the processor itself will stay its current state and during the interrupt, because whenever an interrupt occurs, like it will go for the interrupt service routine. Okay, so it will push all the data to the stack, and it go for the interrupt service routine. It handles all this data. Then when it comes back, it will retrieve. It will pop up from the stack. Okay, so without any instruction overhead, it has the processor has this automatically saved interrupt entry and restored. Okay, an optional wake up interrupt control is there. What is this optional wake up interrupt control? So say for example, the process is idle for a longer period of time. Suddenly it gets a notification. Okay, maybe a burglar alarm. Okay, in that case, it wakes up from the sleep mode and it goes for the interrupt service routine. Okay, when it gets from the burglar sensor, it goes for the interrupt service routine. It wakes up from the because the reason it has to go for the sleep mode is to save the energy. Okay, so whenever the process is not used, it goes for the sleep mode to save the energy. And whenever an interrupt occurs at that point of time, when the process is in sleep mode, it wakes up and it goes for the interrupt service routine and handles it. So optional wake up interrupt control is there, providing ultra low power sleep mode support. So is this clear? Both NVIC and floating point unit is clear for you. We have covered up the core, processor core features, floating point unit, and the NVIC. Is that clear? Just clear on the chat box. Okay, I'll share you the PPT at the end of the session. Okay. Satya Srinivas, don't worry. Like the internship, you'll have communications because currently, you can use the same email ID for the login. Okay. Otherwise, I'm just replying you on private. Okay, so you connect me through this number. Okay, you send you ping me on WhatsApp. Okay. Okay. Clear, teacher. Say Abhishek, say thank you so much. Okay, thank you so much. Yeah, what is handle on thread mode? Arun Kumar, I'll explain the next slide. Okay. Swastik, the floating point unit is actually useful. I'll tell you the use case where it will be useful for you, floating point unit. So whenever you use, say for example, the audio signals, especially the audio signals, and a lot of like the medical signals like ECG signals or EEG signals, okay, the numbers, they will be on the float formats. You'll get lot of float values, Okay, in that case, you have to do the processing with the float. If you round off, when you start rounding off those values, it will go for a round of loss. Okay, so you will lose the data. So in order to avoid that, like they built the processor with the floating point capability, where you can store the floating point and you can process, you can do the operations with the floating point capability without any round off. Later, when you want to grow, like if you want to round off, also you can do round off as per the standards, IEEE standards, IEEE rounding modes. Okay, so that's a floating point unit. Okay, it's an optional unit. If you want, you can use it. If you don't want, like you can turn it off. Okay, now let's go for the memory protection unit. See, I'll tell you the purpose of the memory protection unit is to prevent the application task corrupting the operating system code. Okay, you have the program memory, like you have the program memory and the program is there. Sometimes the application code will corrupt the data of the program memory and the OS will get corrupted. Okay, in order to avoid that, you can protect those memory regions. That's all. Very simple. To protect the memory region. So whenever you store the code, the program code, in order to avoid this application code to corrupt the program code, you can use this memory protection unit. Okay, and like it has like 8 memory regions. You have sub-region disabled so that you can disable or enable the region wise. Okay, so that's the main purpose, is to protect the operating system to getting corrupted. Okay, that's memory protection unit. Again, it's optional. If you want to use it, else you can turn it off. Okay, then you have the bus matrix. Okay, the bus matrix as like I-code bus, decode bus, and system bus interface, like where you can connect with any peripherals through this bus matrix. Okay, so for this, let me show a block diagram for this. Okay, just give me let me check for this. Okay, see, this is the block diagram. It's in page number 18. It's in the data sheet of this architecture. Okay, you have this I bus, D bus, and S bus. Okay, you can see here the flash memory. Okay, you can see the flash memory, which is the program memory. You can see a dot here. It means all the instruction, I code, like instruction can be accessed to only through I bus. You cannot access this instruction by using D bus or not a system bus, because there is no connection at all. Okay, the dot is only at I bus. And see the instruction, you can also have instruction on SRAM. Okay, SRAM, which is a volatile memory, flash is a non-volatile memory. You can still access this I bus by using this to SRAM. Okay, instructions. Data bus, if you want to access the data, it has to be done by the D bus. So decode, flash memory, decode, you can use decode, and SRAM also you can use. You can't use system bus for accessing data on flash memory, or flash memory you can't use, but for SRAM you can use. You can use system bus to access SRAM. Okay, all the AHP peripherals, advanced high performance bus peripherals, you can use system bus. See, that connection is there. And AHP peripheral 2 is also there. Okay, so if AHP is accessible, then APP, obviously APP 1 is also accessible. Okay, because it's connected to the bridge. APP 1 and APP 2 bus is also accessible through the system bus. Okay, and this is the core. This DMA, direct memory access and direct memory access too. Okay, so the purpose of the DMA is, without going for the CPU, the CORTEX M4, you can directly access the peripherals. See, you can see here, like it's the DMA is directly connected to APP1. It means you can access all the peripherals. The DMA controller can access all the peripherals directly to the peripherals. Okay, without going for the ARM CORTEX M4. Is this clear for you? Is this bus? You just go for multi AHB bus matrix. Is that clear for you? So here you have I code, decode, and system bus interface. Apart from this, you also have private peripheral bus interface to connect with the advanced peripheral bus interface. The purpose is to access the flash memory, SRAM memory, as well as the advanced high performance bus, the peripherals, which is the devices which is connected to the advanced high performance bus, and all the peripherals which is connected to the advanced peripheral bus to access all this bus. The purpose of the bus matrix is to access. If you want to see that on the block diagram, okay, this is page number 18. Okay, and you go for page number 14. Okay, sorry, page number 15. You go for it on the functional block diagram. This is the bus, AHB bus matrix. Okay, AHB bus matrix. You can see like it is connected to AHB1, AHB2, and it is also connected to APP1 and APP2. Okay, APP1 and APP2. Is that clear? The bus matrix is clear. See, everything is super. It's super simple. Just type super simple on the chat box. If you found this ARM Cortex M4 architecture is super simple, okay, just type super simple on the chat box. If you found it's very hard to grab, okay, just type it's hard on the chat box. I want to see how many of them are typing super simple and how many of them are typing hard. Okay, can you please explain system bus? Okay, see I don't want any please have conversation related only to this session, because this will act as a distraction for others. Otherwise I'll put this chat on the private mode. Okay, so no one, you can chat only to me and you cannot see other people chat. What do you want? Give me one moment, please. Super simple, thank you. Venkat, thank you. Sid is hard, okay. Tijo, super simple, thank you. Sushmita, simple, thank you. Okay. Raju, like, please, I'll take the all. See, the rest of the questions, attendance link, it will be available only at the end of the session. Okay. Please don't disturb for attendance. Raju, I'll take the questions at the end. Okay. I'll internship on various citizen. I'll take the question at the end. Please. Okay. So, no, like we are only online. Google, we are only online. Please focus only on session now. I'll answer all the questions. Please hold on till the session ends. Okay. The next is debug interface. Okay. See, you have like the debug interface. You have the embedded trace macro cell, instrumentation trace macro cell, serial wire, trace port interface. Everything is debug only. We'll go one by one. Okay. So serial wire debug. So the debug means what is the debug means? Whenever you write a program and if you want to test the program whether the program is working or not, okay, you need some interface to stop the execution of the program to check the values of the registers and everything. So there are two ways you can do this. JTAG is one option. Joint Test Action Group is one. That's a standard. It's for debugging purpose. And the serial wire is a low-cost interface from STM Electronics. So they have serial wire debug port or serial wire JTAG port. It supports both JTAG as well as serial wire debug. Okay, that's first point. The second point is it supports breakpoints. So what is the use of breakpoints? By keeping breakpoints on the program, you can stop the execution of the program at that particular location and you can access those memories and variables. You can see what is there in the memory, what is there in the registers, everything you can check. That's a breakpoint. And you have optional flash patch. What is the optional flash patch? So whenever the code is corrupted on the SRAMs, okay, you can again patch it back from the flash memory. So that is optional flash patch. Okay. So optional flash patch and breakpoint is there. And you have data watch point and trace. So data watch point and trace is used to whenever you want to stop a program at a particular condition, okay, when a data is written or read, or if you want to analyze the data, or if you want to trace the data, then you can use the data watch points. Breakpoint is used to stop the execution of the program at a certain program, at certain program lines. Watch points is used to stop when a condition is met. Okay, if you want to trace the data and if you want to when the condition is met, if you want to stop the execution, then you can use watch points. Okay, and instrumentation trace macro cell, ITM. Okay, ITM is used for printer cell debugging. What is printer cell debugging? Like you can use printer statements to know what is the content of the variables or what is the content of the program. Usually you can't use printf on embedded process because like where it will print, it won't print. When you use printf, where it will print. So it uses printf. You can use printf statements by using ITM. Okay, instrumentation trace macro cell unit. You can print it to a serial wire viewer. Okay, so it supports printf cell debugging. And trace port interface unit. Okay, which is used to interface with trace port analyzer just for analyzing the data, like visualizing the data, like which can connect to a serial wire viewer where you can have a serial wire output, like where you can see the waveforms and everything. Okay, and embedded trace macro cell for tracing the instructions. Okay, so these are the debug features. If it is clear for you, just say clear on the chat box. We'll go for the next one. Okay, is that clear? Is that clear? See, Is that clear? Okay. So coming to the flash patch breakpoints, like whenever you have a buggy code, like it will flash it from this memory. And baselines programmer model, let's go for okay. So how JTAG works? See, JTAG like you have like four serial by debug. You have only two lines. Okay, you have the clock and the data. Like whereas JTAG like how JTAG serial, JTAG clock, JTAG input, JTAG output, JTAG mode select. Okay, you like there's a protocol there like which where you can connect through a emulator and the IDE can connect via the target hardware through a emulator or a debugger. Okay, and you can debug the data. Like usually it needs like 5 lines you have to connect. Like every IC will come up with the JTAG pins. You have JTAG mode select, JTAG input, JTAG output, JTAG clock, JTAG reset. Okay, and this pin has to be connected to the debugger unit. Okay, the debugger unit will have a USB interface which you connect with the IDE, so that the IDE they will be enabling the certain registers to access those to give the breakpoints and everything. Okay, so coming to the programmer's model, okay, so you have the registers like R0 to R, totally 16 registers of that, R0 to R15. So R0 to R15, like R13 is a stack pointer. Okay, you have two stack pointers here, main stack pointer and process stack pointer. You have link registers, So whenever you have a function call, the return address of the function call, return address will be stored on the link register. You have program counter. The next instruction to be executed will be stored on the program counter. Okay, you have two modes. Handler mode and you have thread modes. Okay, thread mode is a privileged mode. You have both privileged and unprivileged mode. It's a normal mode program. So whenever an interrupt occurs or whenever an exception occurs, it goes for the handler mode. Okay, handler mode again is a privileged mode. Privileged modes means it will have access to all the protected areas. Okay, so apart from this, you have program status register, like program status register like XPSR. So R0 to R7 is low registers. R8 to R12 is high registers. If you don't know what is a register, these are nothing but a storage elements. Storage elements which will have, which will store the data or which will store the address. Okay, and so low registers and high registers, and like stack pointer, like whenever the processing thread modes and the handler mode, you can use this main stack pointer as well as process stack pointer. And program status register, when you go for a program status register, like you have like three different types of AP registers. One is application program status register, APSR, and you have IPSR. Okay, interrupt program status register, and you have execution program status register. All these three things are there. So APSR, like whenever you do some operations and you have a negative result, this flag is set, N is set. Whenever you have the result is 0, the Z flag is set. Whenever you have a carry, C flag is set. Okay, overflow, B is set, and saturation. Whenever you have saturation, the Q flag is set. Okay, so this is for APSR, the application program status register. The interrupt program status register will have the interrupt number. Okay, every exception will have a number. So that number will be stored on the interrupt program status register. And what interrupt is currently servicing. Okay, so that detail will be there on the interrupt program status register. An execution program status register will have whether the processor is in ARM or thumb instruction. Okay, so usually here in ARM Cortex M4 by default this thumb. So this thumb will always be set to 1. Okay, so only 3 status registers. Okay, you can access either as the APSR, IPSR, or you can access the entire thing as programs XPSR, program status register. Okay, so that's all about this programmer's model. So coming to the operating modes. Okay, is that clear? Just set clear on the chat box. The programmer model is clear for you. Just set clear on the chat box because we are running out of time. Okay, let's go for XPSR. Okay, for the operating modes, you have two modes. One is handler mode, the other is thread mode. Okay, so thread mode, no exceptions being processed, normal code is executing. That's a thread mode. Handler mode, like whenever you have an exception or whenever you have an interrupt, then it goes for the handler mode. Okay, that's all. It's very simple. And this is the block diagram. I'll explain you the block diagram once. Okay. See, you have this core here. This is the ARM core. You have the bus matrix. Direct memory access 2, direct memory access 1. See, all the GPIOs, general purpose input output, okay, port A, port B, are connected to AHB bus. Okay. See, external interrupt wake up, secure digital input output, that's for MMC card, okay, and timers. All these are timers, USARTs, serial peripheral interface, I2S for audio, okay, and I2S and temperature sensors, ADC, analog to digital converters, see at VDDA, because analog voltage, okay, analog voltage, and you have APP1 bus, I2C, SM bus, okay, SM bus is for like I2C, like internet integrated circuits, system management bus, okay, and you have a serial peripheral interface, user 2, a watchdog timer, okay, and you have timers. All the timers are here, and automatic wake up unit, real time clock, uh, and you have this watchdog timer clock. This is clock. Power on reset, power down reset, brownout reset. Okay, so power on reset, whenever you power on, it resets automatically. Power down reset, whenever the voltage goes below a certain threshold, it resets the processor. Okay, brownout reset, like whenever the process, whenever you don't have a power for the stable operation, it occurs. About brownout reset occurs. Okay, watchdog timer, like whenever a malfunction occurs, it resets. Okay, so that's watchdog timer. Okay, so and you have USB OTG and flash memory SRAM interface. So this is the block diagram. You can go through the data sheets at page number 15. Okay, STM32F411 data sheets. It will be available on STM32F411 data sheets on page number 15. Okay, just go through it once, because this is very, very important to write the code, and the entire memory is mapped. Okay, the entire memory is mapped. So I'll cover up on the tomorrow class, like how the memory is mapped and the comparisons. Okay, so you can download the IDE at this link. I'll share you the PPT. You can download the IDE where you have to install the software for this. Okay, so thank you so much for your time. I'll share this attendance form. Okay, so before that, if you want to purchase this starter kit like STM32F411 nuclear board, which has, and we also have a Node MC logic analyzer, USB cable, ADXL 345 to study both SPI and I2C. Okay, if you want a serial peripheral interface and I2C, DHT11 sensors, LED and 4x4 keypad, relay modules, SAT-05, LCD, breadboard, and jumper wires. Okay, if you want to purchase this, the price comes around like 7,999. Okay, just give me one moment. Let me check for this for you. Okay. Okay, we have limited stocks available. Okay, so you can, the link is there on the chat box. Okay, the link is there on the chat box. It's the price comes around like 8,999 inclusive of GST. Okay, 8,999, like, which also shipment, sure, like which has nuclear board and everything. So you can use it for free autos. You can use it for the ARM Cortex M4 complete series and embedded C programs. Okay, so if you purchase you can purchase this as I999. Okay, the link is there. So for the 3-month internship program, like I'll I'll again enable the offer for you. Okay, so this is only available for 15 minutes. Okay, it's not for 1 hour. It's only available for 15 minutes. So where we have caught up the embedded C masterclass in detail. Okay, which has like data type, address, variable, operators, arrays, UARTs, SPI, I2C, and it's a 30-day challenge. 5+ projects are there in embedded C programming masterclass. Okay, this course will be there, and embedded system masterclass also you will get on this 3-month internship program. It's a 30-day program. So apart from this, you also get the embedded system IoT masterclass, where we cover up 851 ARM7 Cortex M4 LPC 4088 series, PIC microcontroller, and Node MCU and ESP32. Okay, that is also covered up. And IoT masterclass, Azure AWS ThinkSpeak platform. Okay, it's a 30-day challenge. Again, it's a 30-day challenge. It's also covered up, and you have schematic and PCB design. You have 12-day challenge. All these classes will have, you also have additional live sessions, the intensive live sessions with me, where you can communicate on through the chat box. Okay, so 5 courses are included for a 1,499 package. Okay, and you also have, apart from this, you also have the bootcamp sessions on Saturdays. Saturdays live plus recordings, and you have that will be included. You have 10-day intensive live hackathon, which is going to be started on 13th March, 5 p.m. to 6 p.m. It's a live session. It's a live session because in this 30-day series, you'll be having the recorded sessions as well as live sessions parallelly. Okay, it like whereas this intensive is only with live. It's completely live sessions for 10 days, where I'll be covering up much more in detail, like each and every part, and you can all the live session which will be for 1 hours to 1.5 hours. Okay, and this live session is not only on the ARM Cortex series. Sometimes it will be on the ARM Cortex series. You'll get the recordings. But the other live sessions like MATLAB, you have 8051 live sessions, you have IoT live sessions, you have deep learning, embedded AI live sessions. You can come in. That's a lifetime. That's a lifetime validity. Okay. And Hall of Fame page for interviewers. Okay. Your name will be listed on our website, so that like if anyone, like whenever an HR asks us, like we'll share this page, and they'll have access to this page, your phone numbers which you use for the payment. Okay. And so this Hall of Fame, it usually works after 6 months. Okay, now initially they won't call you. Like after 6 months, once you take the internship, 3 months of completion, then you'll have a lot of your name will be showcased as soon as you make the payment, but it will show it's in progress. The internship is in progress. But once you complete, you'll get your resumes will be your contact will be shared with them. Okay, shared with them an internship offer letter personally for you. So you'll get it on Monday. So today we are in off. So like you'll get this offer letter on Monday. Okay. And personally for you. And 3-month internship certificate you'll get. And daily live sessions, Miracle Morning, it's Monday to Friday. Monday to Friday, if you know what we will conduct on these sessions. So this is the content of the session. Like this session is for 40 minutes. Okay. You'll be starting the session with jumping jacks. Okay, 15 jumping jacks for 3 times to get into the peak performance state, just to change your emotional state. Okay. After that, we'll be writing the goals. We'll be writing the goals on the notebook. Like you have to purchase 4 notebooks for the session. One notebook is for writing the goals. I will be giving you clear guidelines how to write the goals in a specific manner, like with the present tense and like with the deadline, and how to write ideas how to achieve these goals. And affirmations, how to read the affirmations. And I'll be reading the affirmations, my affirmations with you. You have to read the affirmation. That's for 5 minutes. And setting the intention of the day. What kind of person do you want to be today, and what attitude do you want to have towards other people? So how to focus on achieve your goals and gratitude. Okay, finally practicing gratitude. So this session will help you to bring out the next version of you. Okay, I can guarantee you, like this session, like because 80% of your success depends upon this mindset. Okay, so the remaining 20% is the skill set. So this session, this is a lifetime, like Monday to Friday. There are certain days we take off. Like I take off for sometimes like the live sessions, the intensive live sessions. I have given a break for 1 day or 2 days. I've taken off. But for this Miracle Morning, it's very rare. I take off very rarely. Like Monday morning to Friday. There's no off. Like even if I'm travel, like I used to conduct the sessions. Only in the worst case, like I was in like trip or something, like I was in flight, or I'm not able to reach you, I am not able to connect with you. In that case, the session will be postponed, will be cancelled. But for the past 4 months, I just take only 1 day. I just take 2 days for the past 4 months. Okay, for the off. Okay, and so all these things. Sorry, this is 5 technical courses and 50+ projects. So, course, lifetime private community, WhatsApp group, unlimited weekend. So if you are not added to the WhatsApp group, people who pay this and not added to the WhatsApp group, don't worry. So Monday morning, the team will be back and they will be adding you to the WhatsApp group. Okay, unlimited weekend live sessions, and individual internship certificate is there, and also have to get the 3-month internship certificate with the offer letter, and lifetime validity for all courses, bootcamp sessions, and 10-day live hackathons. Okay, Hall of Fame page. Everything is at price of 1499. Okay. So thank you so much. I'll share this. Attendance form. Just give me one moment. Let me share this attendance form. Okay, the attendance form is there on the chat box. So Pratish, like you just use currently there's no online simulator. Like I want you to practice. See, it's worth investing on the hardware. The reason is like The reason is like, unless you practice, you'll never get the guts of, you'll never get the guts. If you want to become an embedded engineer, you have to practice. Okay, if you have some other idea like I'm going for full stack development, in that case, then actually you're wasting time attending this program. Okay, so if you want to become an embedded engineer, I'll tell you the why you have to become an embedded engineer. Like, you get a lot of like, what is that? A lot of money on this. Okay, high paid job like here. Okay, so I'll take a go free. Like, it's only for the paid community. Okay, Pratik, Miracle Morning is not for free. It's only for the paid community. Okay, so thank you so much for your time. Okay, Uday, like, I'll share the PPT. Just give me 1 second. Okay, I'll share the PPT. So is there any questions? So this board comes to the debugging. Okay, is debugging is only for the manufacturers or the programmers, and it's not for the final processing of the during process. Yuvraj, the STM32 boards, the board comes with the debugging, like it has the debugger inside. So you can like you can do, programmers can do by yourself. Okay, programmers can do by yourself. If you can do it. Okay. So attendance link is there in the chat box. So apart from this, we also have silver membership. Okay, is anyone who is interested in silver membership? Just let me know. I'll explain you what is there in the silver membership, like the job assistance program. Okay, just type P for permission. If I get 10 P's or 15 P's, I'll explain you. Otherwise, I'm not going to explain the silver membership. What is there? What is the content which we deliver on the silver membership program? Okay, so this program is crafted in such a way like we ensure success for you. This is not about teaching only the stuff, only the microcontroller stuff. It's not like that. We teach you a lot of stuffs, like how to set your goals in the right way, how to set, how to manage money, how to multiply money, how to earn money. Okay, because these things are not taught on any engineering colleges, but we want to teach the skills because these are the things which we have learned in a very hard way. See, I'll tell you one thing. Like, the one skill which I failed to learn on my entrepreneurial journey is the money management skills, which cost me 3 crore rupees. Okay, I lost 3 crore rupees just because of money management. So I'm teaching this skill for free for my students, for the paid students, called a program called a Milner Mindset. It's a 5-hour program. It's an activity-based program, like where I'll be sharing an ebook with you, and you have to do the activity. At the end of the program, you'll have a very clear understanding about money and how to manage money, and what are the things which you have to unlearn in your life. Because unless you unlearn the certain stuff, your brain will never take decisions, because the purpose of your brain is to protect you. Okay, so unless you unlearn this stuff, unlearn this previous experience, the previous experience will never allow you to go out of the comfort zone. Okay, and you will never grow. You will never become a millionaire. If you want to become a millionaire, you have to first unlearn certain things in your life. You have to unlearn and you have to relearn. So the Miller Mindset program will help you to learn, unlearn certain things which you have learned in a wrong way, and it helps you to create the inner world. Okay, to change your inner world, because your success lies on your inner world. Okay, so what you see on the outer world is the impact of your inner world. Like, if you want to see the fruit, say for example, if you want quality fruits, you have to take care of the roots first. The root is invisible. Okay, so only the fruits are visible for a tree, whereas the root is invisible. But the strength of the roots depends upon the strength of the fruit depends upon the strength of the roots. Okay, similarly, your inner world will create the outer world. Okay, the kind of money what you make, the kind of relationship you attract in your life, it's all depends upon your inner world. The more you strength about your inner world, like there are 3 kinds of inner world you have. One is mental, the second is spiritual, and third is emotional. Okay, when you develop this mental, spiritual, and emotional, then obviously like the outer world will get changed, which is the physical world. So these programs will help you to go in depth. It'll teach you in depth. So the link is available only at the Miller Mindset program. So on the Miracle Morning sessions for the Miller Mindset program and everything, we won't write through email or anything. Okay, it's only when you attend this Miracle Morning you'll get the sessions, and you'll have live sessions with me, because this 30 days. So people who paid, no need to attend this 30-day program. You just come and attend the live program, which will have more beneficial. You can watch the videos whenever you want, but we want you to attend the live program because we are meeting live 2 times in a day. Okay, one in the morning 6 to 6:40, the other in the evening like 5 to 6. Okay, 5 to 6, and Sanjay is also meeting at the same time 5 to 6. So just come and attend the live program. So that will give you, so the recordings you just go through it, and if you have any doubts, you can come and ask the questions of the live program. Okay, so is there anyone who wants to know about this? Silver membership, just like P for permission. I'll explain you. I need at least 10 P's. Only like Kachru is giving P. Okay. If there is no P, I got P's here. Sorry. Mohit, thank you. Okay. Mohit, Yuvraj, thank you. Kedar, thank you. Jitchandra, thank you. Pradeep, thank you. Chaitanya, thank you. Sushmita, thank you. Raji Kumar, thank you. Okay. Okay, Srikakulam, thank you. Sumit, thank you. Kedar, okay. Let me explain. I'll share you. Just give me. See, the recordings is not available for the free course only. It's only for the paid members because let me share. What is the things which we caught up on the silver membership. Okay. So we have 3 levels of membership. One is silver membership, the other is gold, and other is diamond. The diamond membership is where we give you a guarantee for 50 lakh of rupees sales. Okay, if you want to start a business, and like if you want to earn 50 lakh rupees in a year, you can choose diamond membership. But like the diamond membership will help you to will help you to earn 50 lakh rupees in a year. Okay, we'll teach you every stuff: how to make a product, how to design a product, and how to design a product, how to sell the product, how to market the product, how to build your personal brand, how to build your company brand, how to influence others, how to sell, how to market. Everything will teach. Okay, so this silver membership, like what you will get on the silver membership, like you have the very first course is the Embedded C Masterclass. Okay, the same thing, the 30-day challenge. The second course, what we have is the Python Masterclass, because the reason we have included Python is also very essential for embedded nowadays, because a lot of processors, they have support for Python. Like you can download machine learning algorithms, deep learning algorithms on the embedded processors by using Python. So you can have Jupyter notebooks on FPGA, Jupyter notebooks on DSP processor. Okay, so Python is also a very essential skills, which we have added the Python course also, and we also added the embedded system and IoT masterclass, and same here, and embedded system and ARM Cortex M4 masterclass. Okay, and we have added the IoT masterclass. Arduino masterclass for 30 days we have added, which will give you more application sites. If you're a beginner, you can start with the Arduino. And we also added the Raspberry Pi masterclass, which is for 30 days, where you cover up much more details about the Python, like robotic operating systems. We have covered up robotic operating systems. We have covered up deep learning, how to implement deep learning on Raspberry Pi, deep learning applications, how to run deep learning applications. Okay, computer vision applications, how to computation. Everything is covered up on the Raspberry masterclass. It's about 30 hours content. And we have added the FPGA masterclass, which is for a 21-day challenge. Okay, how to the basic essential of VHDL programming, how to write a C program on FPGA, how to download Python on Python, how to write a Python program on FPGA. Everything is caught up here. And we have like projects that we have caught up: Zinc, Spartan 6, Verilog, 5+ projects. It's a 21-day challenge. Okay, 21-day course. We have embedded driver development. Unless you work on embedded C and embedded ARM Cortex M4, this embedded driver development will not understand. Okay, you need to cover up the basic 2 courses for this: embedded C and ARM Cortex M4. Embedded driver development is covered up here. Okay, and we also covered up schematic design in PCB design masterclass. It's a 2-lane. See, we know this. You will not go through this recording course, but you will have access to the recording course. The main advantage is the live sessions. Okay, you sit with us for 3 hours or 4 hours or 6 hours in a day. We will help you to learn how to design your own board, how to design the layouts, how to write the program for UART, how to write the program for serial peripheral interface, how to write the program for I2C. Okay, we will teach you the step-by-step process so that you can learn exactly the same thing. Okay, and MATLAB masterclass, we have caught up like 30 days of MATLAB masterclass, covers like 25+ projects are there. In this alone, like 25+ projects are there. It covers like image processing, medical image processing, deep learning, machine learning. Okay, because this is an essential skill if you want to implement artificial intelligence on embedded systems. Okay, and we have AI using MATLAB series, artificial intelligence using MATLAB. That's a 15-day challenge. Where we covered up algorithms like support vector machines, K nearest neighbor, CNN algorithm, okay, and RCNN algorithm, everything in detail. See, if you are a final year students, no need to go for a final year project center. You can take the projects from here and you can submit to the class. It's worth because the projects are worth. Okay, like real-time face recognition, real-time with attendance tracking systems, everything is there. Okay, and 13 like brain-computer interface course is included for 3 hours course, and 14th is resume building mastery, how to build your resumes. Okay, we also have conduct live sessions for you, and 15 is the interview skills, how to attend interviews. Okay, and 16 like we have leadership skills mastery, and 17th we teach how to improve your LinkedIn profile, how to market yourself on LinkedIn. Okay, we teach 16th, and we have we covered up time management mastery. 17th is time management mastery. Okay, and 18th lifetime, you get lifetime private community access, and weekly mastermind sessions. You have access for all the previous recordings. So I'll show you like what is there on the previous recordings. Okay, let me show this for you. Like what are all the sessions we have conducted previously. Like we have almost we have designed a lot of boards, a lot of 851 boards we have designed. We have designed IoT boards. Let me show this for you. If you go, you will have access to all this course. Okay, if you check for the hackathon. Okay, so we have passive income hackathon. Okay, passive diamond membership hackathon is there, intensive hackathon series, A data science, silver membership hackathon. Let me so for embedded system and IoT hackathon. So what are the things? See, like how to design a 851 board. Okay, the complete, it was taken on July 17th. Okay, complete video is there. How to design IoT board. Okay, everything is that. Download resources. If you click download resources, you'll have the resources which is already used, demo zip files which is already there on which is used for the program. Okay, all the schematics and everything will be there. Like, okay, like you can download all the resources. Draw a simple tutorial PCB, how to design a FPGA board. Okay, AI using MATLABs, hackathon on ARM Cortex M4 series. Okay, so all this, like all the previous sessions uploaded. We have conducted sessions on DSP processors. Everything it's under process, so everything is there. Okay, like if passive income, this is for passive income hackathon. Like if you check the passive income hackathon, like money mindset mastery, how to find your niche, okay, how to build your personal brand, Canva masterclass, build and launch your own website, funnel building, how to sell any products through e-commerce website, how to create a payment gateway, LinkedIn mastery, how to create and sell your courses, how to create and monetize YouTube, how to create Facebook ads, how to create Google ads and YouTube ads, how to generate money through content marketing, how to make money through affiliate marketing. So all this, I think YouTube is not covered here, but all this comes into the passive income hackathon. Okay, passive income hackathon. You get all those recordings. Apart from this, like you have bootcamp recordings, you have the mastermind recordings, you have the bootcamp recordings. Okay, 10-day intensive live. You also get the internship offer letter personally for you. Hall of Fame page, whatever you get in 3-month internship, also you get here. Your own portfolio website for resume building. Okay, you will also get how to build your own website for your resume, which is available, which is there. Okay, in circle calls. Okay, so actual value is 19,480. The offer value is 4,999. Okay, and if you have already purchased this course, you can subtract this and you can pay only 3,499. Okay, if you are in the 3-month internship program, you just pay 3,499 rupees. If you already purchased the course, let me share this link for you. So if you want to upgrade for silver membership, the link is there on the chat box. Okay. So attendance link I already shared. Okay, just give me a moment. Let me share it again for you. Okay. So anyone who wants to pay advance for this, like if you don't have money at this point of time for 4,999, you can pay advance 199 rupees, and you can put this on hold. Okay. If you want me to share this advance link for 200 rupees, it's 199 rupees. You can book this for offer for 199 rupees. Like the silver membership offer link is there on the chat box. Okay. If you want to make an if you want to hold the offer, like you can pay the advance. Okay, you can pay the advance for 199 rupees and you can hold the offer. Just type advance on the chat box. I'll share you the link for the advance payment. Okay. So thank you so much for your time. Okay, I'll take your questions now. So anyone needs the advance payment link, let me know, like so that I can share you the advance payment link. Shalini, like the recorded video is only available for the paid members. It's not for the free members because like people are paying money for this. So we cannot provide access, the live sessions access, because there is no difference between the paid community as well as the free community. Okay, so there is no recorded access like for the free members. This answer is for Shalini. Okay. Yeah, PPT I'll share it. Just give me one moment. Let me share the PPT. So is there anyone who wants to get enrolled on the silver membership? Just type advance on the chat box. Okay, I'll share you the advance payment link. Okay, I'll share you the PPT now. Okay, just give me a moment. Let me share the PPT now. Just give me a moment. So any questions you have? So Tijo, the live sessions are not only on Saturdays and Sundays, not Saturdays, the live sessions on daily. You have live sessions from Monday to Friday. Tijo, the live sessions from Monday to Friday. Okay. You have sessions on Saturday also. Sunday also some sessions, special sessions are conducted only on Sundays. Okay. There is no Telugu language. There is no Tirumala Gopichan. There is no Telugu language. Okay. Let me share this PPT. Just give me one moment. Let me convert this to PPT to PDF first. Just give me one moment. Let me share this PPT for you. Okay. Yeah, the link is there on the chat box. Okay. The link is there on the chat box. When this internship classes will start, Jyoti Lakshmi, the internship classes will start from 13th. The intensive live session starts from 13th. Okay, 13th, and you have classes on daily. You have classes on morning, like the miracle morning from 6 to 6:40. The live sessions will be on the evening, and we have not restricted the duration only for 3 months. The certificate will be for 3 months, but the learning is for lifetime. You can learn for lifetime. Okay. It means after 3 months you can't come and attend the live sessions. It's not like that. You can even come and attend the live sessions after 3 months also. And we also upgrade the courses. Like it's not only an ARM Cortex M4. Sometimes we also teach MSP 413, the other series of microcontrollers. Okay, we also teach 851 PIC and FPGAs. So you can also come and attend this other live sessions also. Okay, it's not restricted like free autos. So okay. It's not. So if you want the recordings of those live sessions, then you need to upgrade for the silver membership. For 3-month internship program, all the live sessions you can come and attend for anyone who gets into the 3-month internship program, you can come and attend all the live sessions. But if you want the recordings, you have to go with this. Okay. So yeah, okay. Just give me one moment. Let me check. I think I have provided access for this. Just give me one moment. Yeah. One moment. Let me check this for you. Yeah, I changed this. Anyone with this link? Okay, check. Can you check now? Can you check this now? Can you check it now? Venkatraman, like, can you check now? Like, I'm sharing it back again. Okay. Okay. So, is there any questions? Any questions? Okay, Karthik, thank you. Okay. Okay. So, like, let me. Is anyone who wanted to enroll for this silver membership, like, or anyone who wants to purchase the hardware? Okay, I'll share you the link again for the hardware part, Embedded System IoT Starter Kit. The link is there on the chat box. Okay. So we have Pavan, like on Monday, you'll get the onboarding on Monday. Okay. I'll connect you through phone. Pavan, I'll call you tomorrow. Tomorrow, like I'm free. Like I'll call you tomorrow through phone. Okay. We'll have a conversation. Like I'll put a roadmap especially for you. Okay. Like we'll share like how to get a job, and let's have an agenda of getting a job in 90 days. Okay. Within 3 months. Okay. Within 3 months. This is for Pavan. Okay. So you just follow the calendar. Just follow the calendars. Definitely, like you'll get the job within 3 months. Okay. This is for Pavan. Pavan, you got it? Thank you. There's no recorded. It's all in, like there's no recorded video because, like, I tell you what, the recorded video, like I want to upload it and I don't have time for this. Okay, I don't have time for this. Even tomorrow, like I have a lot of like commitments, like, and I cannot do it for each and everyone. It's not only the you asking for the recorded video. You understand that first. There are a lot of people on the private chat is asking for the recorded video. It's not possible to share for each and everyone. Us, there is no value for it, and because the people who are attending who paid the payment is there's no difference between them and for. So it will create a problem for us. Okay, you can come and attend all the live sessions. The 30 days of live session is free. Okay, and sometimes like it will be a recorded sessions. It won't be a live sessions. We will be playing only the recorded video, but the content is worth because we spend a lot of time for making the content. Okay, making the content. So thanks for the understanding. So thank you so much for your time. Thank you, Naveen Kumar. Thank you, Vishnu. Thank you, Ruchita. Thank you, Saurabh. Thank you, Sanmugaraj. Thank you, and Jarmi. Thank you, Tahur, Mustafa, Gahan, and Chandan Kumar, Shivani, Shravani, and Naveen Kumar. Thank you, Radhika. Thank you, Vengababu. Thank you, Ajay and Irlapan. Thank you, Meghana. Thank you. So thank you so much for your time. Okay, Rahul and Kachru Engel. Thank you, Akula. Thank you. Thank you so much. I'm signing off. Just type P for permission for closing the session. P for permission. Okay. Just type P for permission for closing the session. Thank you so much for your time. Thank you. Have a great weekend. Have a great Sunday. Okay. Enjoy. Have a lot of enjoyment. Thank you so much. I'm signing off. Thank you.